Hello my dear students, welcome to the board. What a joy to see you at the board. How was at the Math Victory Virtual Classroom? Good. Well, in this lesson we're going to talk about the relationship between of a right-angled triangle. Now when Mr. Max said right angled triangle, now what is right angled triangle? Okay, let's draw that. Okay, we know that we have several triangles we learned from our previous lesson. Now right angled triangle, see that when you have a vertical and horizontal, okay, vertical and horizontal, that makes perpendicular to each other. Okay, so perpendicular means it makes a right angle. Very important, okay, because we know we talked about several type of triangles. Okay, one is the equilateral triangle, that means all the sides are equal, and then we talked about isosceles triangle, that means two sides are equal. All right, now keep in mind, equilateral triangle will never make a right angle triangle. Why is that? Because you know that the angle is always what? 60 degrees, 60 degrees, 60 degrees. So it's very important. Okay, now isosceles, yes, you could have isosceles a right angle triangle. Now what is right angle triangle? Right angle triangle is when the angle right there, it's 90 degrees. 90 degrees. When an angle that makes a 90 degrees, that's called right angle triangle. When a triangle is a right angle triangle, that's the only time you can apply Pythagoras theorem. Okay, keep in mind, Pythagorean theorem cannot be applied if it's not a right angle triangle. Okay, very important. Okay, so we gotta understand what is right angle triangle. So now you know what is right angle triangle. So what is right angle triangle? Exactly when the two sides make perpendicular. All right, one is perfectly vertical and one is the other line, the other side is perfectly horizontal to that. Okay, so that makes it right angle triangle. Right angle triangle is, what's the angle is? 90 degrees. Okay, good. All right, now let's talk about what is Pythagorean theorem. All right, okay, so it's very important to apply Pythagoras theorem. Your triangle ought to be right angle triangle. Okay, so let's draw the right angle triangle again. Okay, this is right angle triangle. Okay, whenever you have a right angle triangle, you want to put a small square inside that identify that triangle as a right angle triangle. Okay, now there are three sides. Now keep in mind that the angle, the right angle is this side and this side are adjacent. Okay, that means they're next to each other. All right, so they're adjacent to each other. All right, okay, and this is the opposite side. Now the opposite side is the one you call hypotenuse. Okay, I want you to know this, the term hypotenuse. It's a very important line. Okay, the opposite, that is the hypotenuse. Okay, so when you know this is the hypotenuse, now we can label each side with A, B and C, and that's the standard A, B and C. So to create a relationship between A, B and C is A squared plus B squared equals to C squared. And that is the hypotenuse theorem. Okay, A squared plus B squared equals to C squared. When a triangle is a right angle triangle, when you have this sides and that side, and the relationship between all these three sides are A squared plus B squared equals to C squared. That means if Mr. Mac to say, if I give it right angle triangle and I told you this is 3 and this is 4, and this is a perfect right angle triangle, this length will become 5. How's that? Okay, now let's substitute. Let's put, this is A, which is 3 squared, and B is 4 squared. So let's prove that C squared. What is C squared going to be? Okay, 3 squared is what? 3 times 3, which is what? 9. 4 squared is 4 times 4, which is 16. So 9 plus 16, so let's line it up. 16 plus 9, 6 plus 9 is 15. So 5, we carry the 1, 1 plus 1 is 2. So that gives me 25. So 25 equals to C squared. Now we're looking for C. Okay, so that means we know that to find C, I can take a square root. Alright, the root, square root. Remember from previous lesson we talked about the square root. So when you take a square root this side, I have to also take the square root on the other side. We have to do equally. That's the thing about equal sign. When you have an equal sign, if you square root the whole thing on the, let's say to your right, okay, you have to square root everything to your left. Very important, okay? So that's what Mr. Max doing. Okay, now what is the square root of c squared, which is c? What is square root of 25? Square root of 25, what's the two identical number that multiply will give me 25? 5 times 5, and I only need one of that, okay, which is 5. See, c equals to 5. So that proves it. Pythagoras theorem, okay, which is a squared plus b squared equals to c squared. Very important. You have to sum this up. You have to add them. A squared plus b squared. Sum them up and then take the square root to find this c. Very important, alright? Okay, good. Let Mr. Mac erase the board. Let's talk more about Pythagoras theorem, and I'll be back with you in a few seconds. Alright, my dear students, now the key thing you need to understand, in order to apply Pythagoras theorem, you have to be a what? Right angled triangle, okay? Right angled triangle. Alright, so, and now the thing that right angled triangle, what that means? This means the angle here is 90 degrees, okay? 90 degrees. Now, another thing you want to know is this side and this side are next to each other, and that's where the angle is, and the opposite is what we call hypotenuse, okay? Hypotenuse, very important, okay? Hypotenuse. Now, hypotenuse is the one that represents C, always the longest, okay? The longest line between the three sides. This is the hypotenuse, and which is C. The short line, the short sides makes it A and B. So now to create the relationship is a squared plus b squared equals to c squared, and that is Pythagoras theorem, okay? So again, this side squared with that side squared, when you add them should give you the squared of the c squared, okay? The squared of the c, okay? And that's the hypotenuse, and that's the longest line, alright? Between the three sides, that's the longest, okay? So keep in mind. Let's look at different scenarios. Let's say, for example, Mr. Mac to give you a square and a rectangle, okay? Now, you know the characteristic of a square and a rectangle. A square, as all sides are equal, and what are the angles are? The corners. They all makes right angles, all right? And the same thing with rectangles, all right? With the rectangle, all the corners are right angles, makes it 90 degrees. The only difference between a square and a rectangle is, for rectangle, the opposite sides length are equal. The opposite sides length are equal, but for square, all the sides. Now, if Mr. Mac to draw a line, right, a diagonal line from that corner to this, now that makes a right angle triangle. Okay, this right here, if it's 5 foot A, B, C, D, now the ACD is a right angle triangle. ABC is a right angle triangle, because right there, see that? Okay, the same thing with the rectangle. If I had to put a straight diagonal line from this corner to that, and if I say this is, let's say, MNOP, okay? So the triangle MOP, it's a right angle triangle. The triangle MNO is a right angle triangle, because right there, it's a 90 degrees angle, okay? So the key thing is 90 degree angle. This diagonal is the one makes what? The hypotenuse. The hypotenuse for this triangle and hypotenuse for that triangle. The same thing. The hypotenuse for this triangle and hypotenuse for that triangle. And that makes what this one? This is C. Alright? And this is your A and this is B. Doesn't matter. It can be interchangeable. It can be this one A or B. Doesn't matter. The key thing is you need to identify the C first. Once you know what's C, and then you can put A or B, doesn't matter. Okay? The same thing. Doesn't matter A or B, which side. But this is the C. Okay? That's very important. Once you put that C, you can put this one A and this one B. Alright? Okay, so it doesn't matter which one you choose to be A or B. So keep in mind, okay? Now, keep in mind if it's a isosceles right angle, okay? If it's isosceles right angle triangle, that means the two sides are same. So that means if this is A, this is also A. That means what? A squared plus A squared equals to C squared. They are identical terms. A squared, A squared. That means I can combine them. That means 2A squared equals to C squared. If it's an isosceles right angle triangle. Isosceles right angle triangle. Very important. Mr. Mac has to put that. Because that tells you, if that is not there, if I just give you a triangle like this, and I told you true or false, A, B, C, A squared plus B squared equals to C squared. That's false. Why? I didn't say this is a right angle triangle. It couldn't be anything. See that? It could be right angle triangle. It could not be right angle triangle. So this is not a right statement. If I to put this, it is a right angle triangle. And this is correct. It is a hypotenuse theorem. Okay? Oh, I could have done this. Put a circle, small circle like that. Okay, and then put 90 degrees. Okay, then yes, A squared plus B squared equals to C squared. As long as I put 90 degrees or the small square, which will identify that that triangle is a right angle triangle. Very important, okay, to understand this, okay? Right? Even if I did do, let's say for example, I showed this and I say this is 91 degrees. Will that fulfill the Pythagoras theorem? No. Why? 91 degrees. Pythagorean theorem only apply to a right angle which is 90 degrees. If it's off, even slightly it's off, the length will not matches. Okay, it will not fulfill A squared plus B squared equal to C squared. Okay, keep in mind. Alright, good. I want you to make sure you understand the key thing is the hypotenuse. Okay, the hypotenuse is the one C in order to fulfill this Pythagoras theorem. Okay, A squared plus B squared equal to C squared. The adjacent side, okay, where the right angle is the A or B. You can decide which one you want to give, assign A or B, doesn't matter, but the key thing is the hypotenuse is always the C, which is the longest. Alright, good. Let Mr. Mac erase the board and let's do some few problems finding A, B and C. Okay, and I'll be back in a few seconds. Alright, my dear students, now let Mr. Mac to give you a problem. Okay, let's say Mr. Mac to give you a triangle. Okay, and I told you this one is, let's say, 8, and this one is 15, and ask you to find X. Alright, so how do you do that? So if I give you 8, 15, and X. Very good job. I'm so proud of you. Good job. Yes, you cannot find that length of X using the Pythagoras theorem. Why? Because Mr. Mac didn't give you what type of angle this is. I have to tell you this is a right angle triangle. Then only you can use the Pythagoras theorem. Okay, if I didn't put that, there's no way you can apply the Pythagoras theorem. Now yes, right away you see it's a right angle triangle and you know the two sides length, then you should be able to find the third one. So it's very important. Okay, you got to find identify the two sides of the triangle in order to find the third side. Okay, in this case I want to ask you to find the hypotenuse of that triangle, which is the C. So we're going to label it. We're going to say this is A, this is B, and this is going to be C. Or even though I ask you to find the length of X, but you're going to use Pythagoras theorem, which is A squared plus B squared equals to C squared. So that's why you want to label them as A, B, and C. So we're going to write down A squared plus B squared equals to C squared. Very important. A squared plus B squared equals to C squared. Now substitute. Okay, so we're going to substitute A with the 8, and then we're going to square that. and then b, we're going to substitute with the 15, we're going to square that, and we're going to find out what c squared is going to be first, okay? So 8 times 8 is 64, because it's our timetable range, so we're going to put 64. How about 15 times 15? Okay, it's outside our timetable, so we're going to take 15 times 15, we'll line it up. 5 times 5 is 25, so I'm going to put 5, carry the 2, 5 times 1 is 5, plus 2 is 7, okay? And then I'm going to multiply that with 1 now, straight, we're going to start right there. 1 times 5 is 5, and 1 times 1 is 1, and then I'm going to sum them up. 5, 7 plus 5 is, very good, 12, so I'm going to carry 1, 1 plus 1 is 2. So that gives me 225, okay? Equals to c squared. Now we're going to add them, alright? Okay, in order to find what c squared is, we're going to sum it up. So we're going to take 225, we're going to add that with 64, okay? So 64, 5 plus 4 is 9, 2 plus 6 is 8, and then we're going to carry the 2 down. So which gives us c squared equals to 289. Now we want to find what is c. In order to find c, which is in the form of c squared, I have to square root the c squared. So when I square root the c squared, okay, I have to also square on this side. So very important, okay? Equal signs, very important. When you are equal sign, you treat both sides equally. Like Mr. Max said very beginning, equal signs like your parents. If they give you an apple, they'll give your brother or sister an apple. If they give you an orange, they'll give it. See that? They always do the equally. Whatever you do, okay, to your left of you, okay, and you also have to do to your right. Alright, so very important, okay, so keep in mind. So in this case, I'm square rooting the c squared. Okay, I have to square root the 289 as well. So that tells me c squared. When you square root of c squared, we'll give you c. Now we want to find out what the square root of 289. You want to find a number, identical number that times it will give you 289. Okay, so we know it's not going to be 15. So let's try 16 and see if that will work. Okay, so we can take 16 times 16. Okay, 6 times 6 is 36. Oh, right away it tells you it's not going to be 16, because that 6 times 6 is 36. So because we know we want it to be 9. Alright, so how about 17? Okay, 7 times 7 is 49. That gives you the hint right there. Okay, well, continue. Okay, make sure you get it to 289. Alright, so 7 times 1 is 7, plus 4 is 11. Okay, now I'm going to start with 1. I'm going to start right here. I'm going to multiply with 1. I'm going to start right there. 1 times 7 is 7. 1 times 1 is 1. Now I'm going to add them. 9, 1 plus 7 is 8, 1 plus 1 is 2. Oh, right there. So that means 17 times 17 is 289. Okay, so we're going to say we're only going to take 1. Okay, so in other words, 17 times 17 is 289. Square root means you just pick 1 out of that 2. Okay, so we just put right there, c equals to 17. So x equals to 17, and that's the length. Alright, in this case, let's say we're using centimeters. Alright, so I'm kind of using the numbers, okay, but you just, when I say talk about length, just keep in mind we're using some kind of length unit, in this case centimeters. Alright, so we found it right there. Pretty easy, isn't it? Very straightforward. Okay, alright, good. Let's do another one. Okay, let's say for example, Mr. Mac to give you, okay, another triangle, okay, right angle triangle. So this time I gave you, this one is let's say 15, and this one is 25, and I want to find y. You said, Mr. Mac, you're always given this too, but you're giving this too. That's what we're going to talk about. What happens if I give you this too and ask you to find that? Okay, now keep in mind, in order to apply Pythagoras theorem, you got to have the two sides. You need to know the two sides, identify the two sides before you can find the third side, unless it is it's a isosceles triangle. Okay, unless it's an isosceles triangle. Okay, why is it isosceles triangle? Because you know the two sides are equal. All right, the two sides will be equal, so it will be easier. We only need one side, okay, in order to find the length if it's isosceles right angle triangle. If not, you need to know at least two sides. I mean, you have to know two sides. I shouldn't say at least, you need to know the two sides. Okay, in order to find the third one, if it's not an isosceles right angle triangle, if it's not, okay? Alright, okay, now, so how do we do that? So now let's write down the formula. What's the formula for Pythagoras theorem? A squared plus b squared equals to c squared. Now this time we're looking for what? This side. Okay, let's label them. This is A, this is B, and this is C. Alright? Okay, we're going to say A, B, C. Alright? You're looking for what? B, which is unknown. We don't know what B is going to be, which is the Y. We don't know what Y is. Okay? B is the one that we're looking for. So that means we want to isolate B squared, because we're looking for. So when I'm looking for something, I isolate that and then move anything around it to the other side of the bridge. Okay, cross the bridge. Okay, so we're going to take A squared cross the bridge. And what's A squared doing to B squared? It's adding. So we're going to take that across the bridge. So addition across the bridge becomes subtraction. Okay, now look at that. B squared equals to C squared minus A squared. In order to find the B squared, in order to find the, eventually we're going to find the B, but B squared equals to C squared minus A squared. If this one is B, let's say if it's the other way around, if this one to be B and this one to be A and this one's still the C, okay, let's say, so now it's still A squared plus B squared equals to C squared, and I already know this, I know this, okay, but I'm looking for A squared, which is unknown. Okay, let's put a circle so that way we know we're referring to that one. Alright, I'm looking for A, which is the A squared. When you're looking for, that means who got to go? The B squared. B squared got to go. So that means A squared equals to C squared plus, cross the bridge, becomes minus, right there. See that? So it doesn't matter which one goes, you still got to minus it. Alright? You move A across, will become minus. You bring B across, will become minus. To find either one of them. Alright? If you want to find C, you just add them to find the C squared. Alright? Okay, now let's do that. Okay, so let's go back to this one. So we don't know what B is, okay, but we know what C. C is what? 25, okay? So we can write down here, B squared equals to C squared minus A squared. And we know C squared, C is 25, okay? So we're going to put 25 squared. And we know A is what? In this case, A is 15, okay? So we're going to say 15 squared. Okay, I'm just going to erase this so it won't confuse you. What is that? Okay, let's erase that, okay? Alright, let's just erase this up right now. Alright, okay, so 20, now we're going to multiply them out. So that makes B squared. So we're looking for B squared, okay? So we're going to power them first and then subtract and then find the what's B squared equals to, okay? We got to power them first, okay? Power them out, alright? Okay, let's do that. So 25 times 25. 25 squared means 25 times 25. So we're going to put 25 times 25, because you know that 25 squared means 25 times 25. Alright, so we're going to line it up. 5 times 5 is 25, so 5 carry 2. 5 times 2 is 10, plus 2 is 12. Okay, then we're going to start right here. 2 times 5 is 10, carry 1. 2 times 2 is 4, plus 1 is 5. Okay, okay, now we're going to add them. 5, 0 plus 2 is 2, 1 plus 5 is 6. Okay, so that gives me 625. Now I'm going to times 15 times 15, because 15 squared is what? 15 squared is 15 times 15. Okay, so let's line it up. Okay, 15 times 15. Okay, 5 times 5 is 25, so 5 carry 2. 5 times 1 is 5, plus 2 is 7. Okay, so we're going to times with 1 now. We're going to straight come down here. 1 times 5 is 5. 1 times 1 is 1. We're going to add them. 5, 7 plus 5 is 12. So 2 carry 1. 1 plus 1 is 2. So that gives me 225. Okay, so we're going to take the difference, alright? We're going to take the difference. So we can take 625. Okay, so let's take that 625. We're going to subtract that with 225. 5 minus 5 is 0. 2 minus 2 is 0. 6 minus 2 is 4. So that gives me 400. Okay, so that means what? B squared equals to 400. But we're looking for B. not b squared, because we want the length of b, which is y. So what I have to do? I have to square root the b squared in order to find the b, am I right? So I have to square root. If I square root on this side, what do I have to do on the other side? Also square root. Very important. Very important, okay? So that makes b equals to, we want to find a number that multiplied by the same number will give me 400. So can you think of that? Okay, let's find what would that be, okay? Okay, so you know that 400, okay? So how about 20 times 20? Why did I pick 20 times 20? Because look at that. 4. 2 times 2 is what? 4, okay? And you got 2 zeros. So that's why I kind of thought 20 would be the ideal number. See, that's what it is. You make some judgment. When you're trying to figure out what could be the possible number, you look at 400 and you say, well, there's a 4 and there's a 2 0. When I multiply 2 zeros, when I 0 and 0, it will actually give me 2 zeros. And 4, I can see 2 and 2, 2 times 2 is 4. See, that's how you come up with that. Okay, trial and error, alright? Because if you didn't get the right answer, then you try different. See that? So that rather than trying to go by 15 and then 16 and then 17 and then 18, 19, see that's going to take a long time to come up, find out what would be the square root of 400. Am I right? So to make the judgment, you look at that 400 and analyze it and see what could possibly 400 be that I can use it in my trial and error to see if I can get to 400. In this case, Mr. Mac thought could be 20. Okay, let's find out. 20 times 20 gives me 400 or not. 0 times 0 is 0, 0 times 0 is 0. Then I'm going to start with 2. I'm going to start right there. 2 times 0 is 0. 2 times 2 is 4. And then I'm going to add 0, 0, 4. 400 right there. That means the square root of 400 is what? 1 of the 20. Okay, so that means 20. So b equals to 20, which is y. Y is 20 right there. Pretty easy, isn't it? Okay. Alright, so keep in mind, not necessarily always I'll ask you to find the hypotenuse. I would give you the hypotenuse and I would have given you one of the sides and ask you to find the other one. Then you use this. A squared plus b squared. Always start with a squared plus b squared equals to c squared. And then ask yourself, what am I looking for? I'm looking for b, this side. Then isolate the one you're looking for. Move everything surrounding it. See that? Alright? Okay, good. Let Mr. Mac erase the board. Let's do more. I'll be back with you in a few seconds. Alright, my dear student, let's do another problem, okay? I'm going to go give you a little bit challenging. Well, there is nothing challenges my students, alright? Okay, good. Let's do that, okay? Let's see Mr. Mac to give you a triangle, alright? I told you it's a right angle triangle. The area, okay, the area of that triangle is equals to 30 centimeters squared, alright? And I gave you one of the length. I told you the length is 12 centimeters. And I asked you to find y. I wanted to find the length of that. So I say this is A, B, C. So find the length of AC. So what is AC? The hypotenuse. Okay? So it's a right angle triangle. That means what method we're going to use? Pythagoras theorem. Okay, then you say, Mr. Mac, you only gave us one length. You told us earlier you gotta have two lengths in order to able to find the third one unless it is a isosceles. In this case, you didn't even tell this is an isosceles. You're right, I didn't tell it's an isosceles triangle. I just told you it's a right angle triangle. One of the side is 12 centimeters and ask you to find the hypotenuse. But wait a minute, I gave you something else. Area equals to what? That's right, 30 centimeters squared. Should you be able to find the length of this one? Yes. From our formula. What's our area formula? Okay, the area formula which we learned previous lessons, have height times base. Okay, height times base. All right, because you know the base is what, 12 centimeter right there. All right, and you don't know the height, which is this right there. But you know the area, which is 30. So let's put that. So 30 equals to half h, and what's the base? 12. Okay. Now ask yourself. You're looking for h. Who got to go? everything surrounding h got to go. All right, let's do one by one. All right, so we're going to take, let's start with the half. All right, 1 over 2. Now 2 is dividing, pretty much this is what this is, h over 2, 12, or another word, 12h over 2. That's the proper way of writing it. All right, okay, now ask yourself, 12 divided by 2 is 6. See, that you simplify before you take it across, so that'll be easier. All right, so now you know 30 equals to 6h. So you're looking for h, who got to go? 6. And what's 6 doing to h? It's multiplying. So multiplication across the bridge becomes division. Alright, so that means I'm going to take the 6 across the bridge, so h becomes 30 divided by 6. Now remember, it's the 6 is the one dividing. See that? You got to put the division in front of the 6. That's why I can move the 30 this side, put the divide 6. See that? So 30 divided by 6 is what? 5. So h equals to 5. Now, if you don't want to simplify, let's say it couldn't be simplified. All right, let's say we don't want to go to this level. How do you do that? Same thing. Okay, let's rewrite that one. Okay, we know 30 equals to 12h over 2. Now, what's 2 is doing to h? It's dividing. Division across the bridge becomes multiplication. So 30 times 2 when I bring that across the bridge. All right, okay, so now I'm still isolating h. 12 still there, so I got to take 12 across. Okay, what's 12 doing to h? It's multiplying. Okay, so 12, which is multiplying across the bridge, becomes division. But before that, what's 30 times 2? Okay, so 30 times 2 is 0, 2 times 0 is 0, 2 times 3 is 6, so 60. Okay, so 60 equals to 12h, so h equals to 60 divided by 12. From the timetable, 60 divided by 12, it's what? 5. So h is 5. See that? Same thing. Alright? It's better if you simplify. If you couldn't simplify, yes, of course you want to use this method right there. If you can simplify right here, you can reduce it down, easier. See that? Right away you got the answer. Okay? So that's the purpose. You want to reduce it down, make it easier to take it across to solve it. Okay, good. So now we know this height is what? 5 centimeters. See that? Now you know the two sides, the length of two sides of the right angle triangle. Will you be able to use the Pythagoras theorem? Will you be able to use Pythagoras theorem? Yes. Okay, so let's write that out. Okay, let's write down the Pythagoras theorem formula. Okay, a squared plus b squared equals to c squared. So let's label this one's A, this one's B, and this one's C. Very important, label them. Alright? So that's where you know this is your hypotenuse. And this two length you're going to substitute. Okay, let's substitute A with 5, then we're going to square it. B with 12, we're going to square it. And we're looking for C. Right? Let's find what C squared first. Okay? So 5 times 5 is 25. It's in our timetable range. 12 times 12 is also in our timetable range, 144. We want to find what c squared is going to be, okay? We're going to add these two numbers, 144. We're going to line it up with 25. 4 plus 5 is 9. 4 plus 2 is 6. And then bring 1 down. So 169 equals to c squared. But I'm looking for c. That means what I have to do? Square root. If I square root, c squared will give me c. See that? If I square root to your right, I also have to square it to your left. Very important. That's the principle for equal sign. Okay, that's the equal. Alright? Whatever you do, whatever operation you do, you got to do both sides equally. Okay, equally. That's what equal means. Alright? Okay, so square root of c is what? C. Square root of 169 is? Well, you know that you already got 12 is 144. Okay, 12 times 12 is 144. The next possible number will be 13. Okay, let's find out. Alright? Don't just say, well, it could be 13, just put down 13. No, do it. Times it out. Make sure it comes out to be right. Okay, 13 times 13. Okay, 3 times 3 is 9. Ah, that already given you a hint. Okay, 3 times 3 is 9. 3 times 1 is 3. And then I'm going to start right there. 3 times 1 is 3. 1 times 3 is 3. 1 times 1 is 1. Now I'm going to add them. Alright, 9. 3 plus 3 is 6. And then 1 right there. 169. Okay, that means I only need 1 13 times 13 is 169. When I square it, I only need 13. So that means C is 13, Y equals to 13 centimeters. See that? We found it right there. And you can always tell that 5, 12, 13. Because this is the hypotenuse, the longest line, always have the longer than 5, longer than 12. Very important. Hypotenuse always bigger. The number always bigger than the other two sides when it's a right angle triangle. Alright? Okay? Good. Understand? Alright, good. Well, let's erase the board and guess what? Hands-on practice. That's right. Let's see what Pablo's doing. He's busy putting some hands-on practice. He's been working really hard because he wants the best. And just like Mr. Mac, want the best for you because you are the best. Alright? Alright, my dear student. I'll be back with you in a few seconds, okay? I'll be there. Alright, my dear students, are you ready for some hands-on practice? I know you are. Alright, let's see if Pablo is ready. Yes, he's ready and waiting to come out and hand over the worksheet. Alright? Okay, Pablo, come on over. Pablo, our dear Pablo, come on over. Alright, my dear students, Pablo's going to hand over the worksheet to you. Now, once you are done, invite Mr. Mac in, okay? Now be sure to pause the video, alright? Okay, here it is. Have fun. Oh, good. Alright, let's do it. Alright, let's do it together, okay? The first one, identify the hypotenuse for each of the following triangles, okay? So we want to identify the hypotenuse. So what is hypotenuse? Okay, let's draw the triangle first. Okay, 1A. So we got right angle triangle, alright? And we know that the hypotenuse is the longest side of the triangle, of the three sides, alright? So which would be the longest? If I say this is, let's say RST. So what would be, which one would be the longest? Of course the RT is the longest. Always the opposite of the right angle, alright? Opposite of the right angle, okay? So in this case, and that is the hypotenuse, okay? Keep in mind, that is the hypotenuse. So how do we identify that? One way of doing it is, the longest line always will be the opposite of the right angle. See that? The opposite, okay? So RT. So RT is the hypotenuse, alright? Good. And what about for B? So B, you've drawn the diagram slightly slanted, okay? Doesn't matter. The thing that you want to look for is what? Let's see, XYZ is the right angle. XYZ, the right angle is right there. And the opposite of that side would be this right there. So XZ is the longest, because that is the hypotenuse, okay? And that's the hypotenuse, okay? You got it? Good job. Okay, good. Problem number 2. True or false? The triangle below LMN, A squared plus B squared equal to C squared. Okay, so problem 2, you're given a triangle and then you're given an angle is 95 degrees. 95 degrees, is that a right angle? No, it's not. Okay, it's more than 90. Okay, so 95 is not a right angle triangle. So right away you know it's not, it's false. Okay, so in other words, A, let's say this is A and this is given B and this is C, so A squared plus B squared is not C squared. Why? Because this is not a right angle. So in this case, they gave you A squared plus B squared equals to C squared. Alright, so they gave you in the form of like this. So this means false. Okay, so this is false. Why false again? Because the angle is not 95 degrees. It's very important. It has to be a right angle in order to fulfill Pythagoras theorem of a squared plus b squared equals to c squared. Alright? Okay, good. Alright, let's look at problem number 3. So problem 3 you're given. Well, let Mr. Mike erase the board. I'll be back with you in a few seconds. Ready for problem number 3? Okay, let's do problem number 3. Problem 3 says find the value of the unknown. Okay, unknowns. Alright, so it says no calculator. Alright, we're not going to use the calculator. Okay, let's do 3a. Okay, 3a, you're given a right angle triangle. Very important. It's a right angle triangle. How do I know it's a right angle triangle? Right there, the small square inside the angle, one of the angle, okay, is given as a, that identifies that's a right angle triangle, okay. Then you're given this is 9 centimeters and this is 12 centimeters. And I want to find what's u. U is the unknown, alright. So, the moment you see a right angle triangle and you're looking for one of the side and you're already given 2 sides and you use the Pythagoras theorem. What's the formula? A squared plus b squared equals to c squared. So let's identify, this is A, this is B, and this is going to be the C. Very important, okay? Why that C? Because that is the hypotenuse, okay? The longest line, okay? The side, the longest side, which is C. Okay, now let's substitute. A is 9, so we're going to put 9 squared, and B is 12. 12 squared equals to C squared. Alright, and it's a 9 times 9 is 81. So now timetable range plus 12 times 12 is 144. So equals to c squared. Let's add them, okay? So you got 144. We're going to add that with 81. 4 plus 1 is 5. 4 plus 8 is 12. 2 carry 1. 1 plus 1 is 2. So that gives us 225 equal to c squared. But I'm looking for c. So that means I'm going to take a square root. When you have a square, you take a square root to find the c, okay? Or you want to just find the without a square, okay? So we're going to square root both sides. So when you square root a c squared, will give you c. Square root of 225. Well, we know that 12 times 12 is 144. So let's try 14 times 14. Let's see what happens. 14 times 14, okay? So 14 times 14. 4 times 4 is 16. 6. No. How about 15 times 15? 5 times 5 is 25. Maybe that might work. So let's do that. 5 times 5 is 25. So 5, 2. 5 times 1 is 5. Plus 2 is 7. 1 times 5 is 5. 1 times 1 is 1. Now let's add them. 5. 7 plus 5 is 12. 2 carry 1. 1 plus 1 is 2. 225. That means 15 times 15. So you know that 15 times 15. Okay? When you square it, you only need 1. So that means C equals to 15, alright, which means u equals to 15 centimeter. Alright, 15 centimeters. Alright, let's do problem B. Okay, so B you're given. Alright, the triangle is kind of slanted this way, but doesn't matter. But make sure look for the right angle triangle right there, okay? And you're given this is T, and this is 3 meters, and this is 5 meters, alright? And then, so Y, and this is X, and this is Z, alright? Okay, we want to find the length of YZ, which is T, the unknown. Now, if this kind of confuses you, so if you want to redraw it, you can do that too. If that helps you, okay? But be careful, make sure you assign them properly, okay? See that down right there, and that's the Y. X, you can just give one of them X and then Z, alright? Doesn't matter, right? So Y to X is what? 3. Y to X is 3. And then Y to Z is T. Y to Z is T. And then X to Z is 5. Okay, make sure you, okay, if you do redraw it such a way that you can understand how that orientation is, alright? So make sure you follow them, trace them exactly, alright? Very important, because if you put it wrongly, your answer is going to be wrong. So now, will you be able to use the way we always able to see it, okay? So if that helps you, go ahead and do it. If you can continue from here, that's good too. Okay, so now we know that This is a right angle triangle. That means we can use the Pythagoras theorem with formula, which is a squared plus b squared equals to c squared. Now look at this. Zx is the hypotenuse, but you're given c and we're looking for t, which is, we can, how about we do this? Let's assign a, b, c, alright? Because that's the hypotenuse, always the c, okay? A is the one we're looking for, which is the t. See that? That means we're looking for this. We're given b, we're given c. I have to isolate a in order to find a, am I right? So that means b, I have to go across this bridge, okay? So that means a squared equals to c squared minus b squared. So I know c is what? 5. So 5 squared minus b is 3. 3 squared. And I can find what a squared is going to be. Am I right? So 5 times 5, because 5 squared is 5 times 5, which is 25. 3 times 3 is 9. So 25 minus 9. So let's line it up. So 25 minus 9. 5 minus 9, I cannot borrow from 2. 2 becomes 1. 1, 5 becomes 15. 15 minus 9 is 6. And then bring 1 down. So which is 16. A squared equals to 16. But I'm looking for a. That means I'm going to take a square root of that a squared. That means I have to also square root that side. So square root of a squared will be a. Square root of 16 is, what is 2 identical number times give me 16? Exactly, 4 times 4. Okay, because I know 4 times 4 is 16, but I only need 1. When I square root, I'm only looking for 1 out of that, which is 4. That means t equals to 4 centimeters. See that? Pretty easy, isn't it? Okay, so very important, alright? Understand, make sure you're able to identify hypotenuse, okay? So that's the hypotenuse, see, but you're given. So that means we're looking for the unknown, would be the one of the side length, alright? Which is, we're looking for that one, the A, okay? So there we are. You got it? Good job. Alright, good. Let's do problem C. Well, let Mr. Mac erase the board and we'll do problem C, and I'll be back within a few seconds. Okay, you ready for C? Alright, let's do C, okay? 3C, you're given a right angle triangle and you're given 4 centimeters, okay? And then 12 centimeters and M, you're asked to find M, okay? So let's do this RST, okay? You want to find M. So what do? We're going to use the Pythagoras theorem, because first we're going to identify hypotenuse, which is right here. That means that makes it C. That means we can assign this A and this is B. Alright? So once you know the hypotenuse, right away put C. Then you can put either A or B on either side. Alright? So we know that A squared plus B squared equals to C squared. Make sure you memorize that. Alright? You gotta memorize this. There's no shortcut. Pythagoras theorem is A squared plus B squared equals to C squared. Alright? Good. So now let's substitute, okay? So A is what? 4. So 4 squared, 12 is B, which is 12 squared equal to C squared. So 4 times 4, the 4 squared means 4 times 4, okay? That means 16. 12 squared means 12 times 12, which is 144. So we can add them, okay? 144 plus 16, 4 plus 6 is 10, 0 carry 1, 1 plus 4 is 5, plus 1 is 6, and then bring 1 down, so 160. 160 equals to C squared. Now, we're looking for C. We're going to take the square root, okay? The square root of C squared and square root of 160. So that gives me C. Now look at that, 160. It's not square rootable to give us a perfect whole number, okay? So we're going to simplify that. Now you know that 160 also means 16 times 10. This is we learned from a root lesson, okay? Square roots, alright? Okay, now 16 times 10, which, how do I, 116 times 10 give me 160. Why did I pick 16 times 10? Because I know the square root of 16 is what? 4. So that means I can take the square root of 16 and square root of 10 separately. Because when you multiply, you can break them like this. What is square root of 16? 4. 4 square root of 10 equals to C. So now I know M equals to 4 square root of 10 centimeters. If you ask you not to use calculator, this is the type of answer they're looking for. Because calculator gives you decimal. So we don't want decimal. Alright? When you have 4 square root of 10, that means without calculator. You solve it without, using calculator. Alright? Keep in mind. Again, if you couldn't do this way, you can use the one-leg ladder method. Okay, what is one-leg ladder method? Alright, we put the 160. You start with the smallest, which is be 2. 2, so 16 divided by 2 is 8, and then just bring 0 down. 2, 8 divided by 2 is 4, you bring the 0 down. And then divide that by 2, 4 divided by 2 is 2, bring the 0 down. Alright, 2, 20 divided by 2 is 10. Okay, divided by 2 is 5. Divided by 5 is 1, all the way to the 1. Alright, now see how many we can get a pair. You got 1 pair, 2 pair. Alright, the one doesn't have pair. 2 times 5, which is 10, goes inside the square root. Alright, 10. The one that has a pair, you only need 1. 1, 1, which makes 2 times 2 is 4. See that? Right there. That's another way of doing it. Okay, because you're taking the square root of 160. That means you're looking for numbers that identical number that times that will give you the square root of that number inside. Alright, okay, so that's why you just pick 1 out of that. So that means I take the 1 out of that 2 and then 1 out of that 2, and I multiply that 2, gives me 4. This one didn't have any pair, I times them, put it back inside the square root. Alright, because I'm taking the 160, I'm breaking out. Alright, does that make sense? Okay, good. We learned a lot on the root lesson. Alright, square root lesson. Alright, make sure you go back. If you think you need to brush up this, make sure you go back and refresh that. Alright, okay, good. Alright, well, let Mr. Mike erase the board and we'll do problem number 4, and I'll be back within a few seconds. Alright, my dear student, you ready for problem 4a? Okay, problem 4a says find the value of the unknowns. Alright, okay, no calculator. Alright, so problem A, the area of the triangle below is 150 centimeter square. Find the length of u. Okay, so we're given a right angle triangle. So 4a, you're given a right angle triangle. So that's very important. In order for us to able to use the Pythagoras theorem, we got to have a right angle triangle. And then you're given 15 centimeters, and then he asks you to find u. So you're given RST. And what else is given? The area of that triangle. So what's the area of that triangle? The area of that triangle has been given 150 centimeters squared. So now we're going to find the length of u. But how are we going to find? But there's only one is given, but we didn't give, there was not. ST is not given. Very good. There you go, right there. That's going to help us to find ST. Why is that? Because we know the area of a triangle is what? Half height times base. Alright? You're given the height, which is 15 centimeters. Can I find the base? Yes, because I also know the area. Area is 150. Okay, so let's find the base. That means I have to isolate. Now 15 divided by 2, I cannot, so I have to move the 2 across. Okay, so 150. Now what's 2 is doing towards b? It's dividing. Division across the bridge becomes multiplication. Alright, multiply by 2, give me 15b. So I'm looking for b. What's 15 doing to b? It's multiplying. So cross the bridge becomes division. So b cross the bridge becomes division. So 150 times 2 divided by 15. See, I can write like this too. Alright? Now look at this. 15 and 150. I can divide this by 15 and I can divide this by 15. See that? I'm simplifying it. Alright? So that means 150 divided by 15 is 10, because 10 times 10 times 15 is 150. Okay? So it's going to be 10 times 2 over 1. 15 divided by 15 is 1. So 10 times 2 is what? 20. Over 1, which is 20, equals to B. So we know B is 20 centimeters. See that? So this is helping you to find the length of TS. Once you know TS, you should be able to, and you already given RS, you should be able to find U. So now we know the two sides, the length of two sides, and it's a right angle triangle. So can I find RT? Yes. By using what? Exactly, Pythagoras theorem, which is using the formula a squared plus b squared equals to c squared. Now, so which will be the c, the hypotenuse, opposite of the right angle. Okay, this is a C. I can put this on A and B. Doesn't matter. I can put this on A or B. Doesn't matter which one you want to do. All right. Okay. So now we know that A squared plus B squared equals to C squared. A is 20, so I'm going to do 20 squared, and B is 15. 15 squared equals to C squared. So 20 times 20. Okay, you know that 2 times 2 is 4. When you times things 2 with a 0 and 0, it'll be 2 zeros. So it'll be 400. Alright, this is the shortcut I'm showing you. Alright, otherwise you got to times it out like this: 0 times 0 is 0, 0 times 0 is 0, 2 times 0 is 0, 2 times 2 is 4. See that? 0, 0, 4. Okay, so always keep in mind 2 times 2 is 4. You got 2 zeros, you put 2 zeros behind it. That's a shortcut of doing it. Alright, so 400. How about 15 times 15? So let's do that. So 15 times 15. Okay, 15 times 15. 5 times 5 is 25. So 5 carry the 2. 5 times 1 is 5 plus 2 is 7. Then I'm going to multiply with 1. I got to start right here. 1 times 5 is 5. 1 times 1 is 1. Now I'm going to add them. 5. 7 plus 5 is 12. 2 carry 1. 1 plus 1 is 2. So that gives me 225. So now I'm going to put right there 225. Oops, there's a plus right here. Okay, so I don't know why Mr. Mac put it times plus. Okay, so we're going to add this too. Alright, we're going to add this too. Okay, so we're going to line it up. So we're going to take 400. We're going to add that with 225. 0 plus 5 is 5. 0 plus 2 is 2. 4 plus 2 is 6. So that gives me 625 equals to C squared. But I'm looking for C. That means I'm going to take a square root. That means I have to square root on this side also. Very important. Okay. So C equals to 625. Whenever you see a 5, you want to look for a number. When you're square rooting a number that has a 5 on the very end, the possibility is that number that you're going to get a square root, the result also has a 5 behind it. Okay, so you know you have 20 and 15, and you know this line has to be longer than that, longer than this too. Okay, so that means what's longer than 20? Oh no, bigger than 20 that has 5 in the back. How about 25? Okay, let's try with 25. Okay, let's try 25 times 25. 5 times 5 is 25. See that? All right. 5, I've carried the 2. 5 times 2 is 10 plus 2 is 12. 2 times 5 is 5. 2 times 5 is 10. 0, carry 1. 2 times 2 is 2 plus 1 is 5. Alright, so we're going to add them. 5, 2, 1 plus 5 is 6. Oh, look at that. 625. See that? That means this one is 25 times 25. So 25 times 25. But we only need 1. So that means C equals to 25. Alright, which means U equals to 25 centimeters. Pretty easy, isn't it? Okay, so the key is in this problem is they gave you this information and they only gave you one length. By given the information, you should be able to find another length, another side of the length, okay, of the triangle, the right angle triangle. Once you know that, then using the Pythagoras theorem formula, alright, right there, you found U equals to 25 centimeters. Alright, good. I'll let Mr. Mac erase the board. We do problem B. Okay, I'll be back with you in a few seconds. Alright, my dear students, ready for B? Okay, let's say B, you're given, find the length of AD. So you're given a square and then a triangle on top of that square, alright? Oops. Okay, then we're given a square and a triangle on top of that, okay? How do I know it's a square? Because you're given this line right there. That means what? If this is 4 centimeters, so what this will be? Also 4 centimeters. What would this be? Also 4 centimeters. What would this be? 4 centimeters. See that? That's the characteristic about square, okay? And then you're given the length from that end to that is 7 centimeters, okay? And you're asked to find y, and you're given, then you're labeled as A, B, C, D, okay? So they ask you to find the length of AD, which means y, alright? We want to find what y is. So in order to find y, and you're told this is a, it's given, it's a right angle. That means if this is right angle, this also will be a right angle. That makes this is also a right angle, alright? That tells you what? This is a right angle triangle. That means I can use Pythagoras theorem. But look at this. In order to use the Pythagoras theorems, I need at least two length, the two sides, in order to find y. So I know this already, but I don't know, I wasn't given. But wait, you're told from A to B is 7 centimeters. And you know from year to year is what? 4 centimeters. If this is 4, what is this going to be? Exactly 7 minus 4, which is 3 centimeters. See that? So now I know this is 3 centimeters. Can I find y? Yes. Alright, so now let's take that triangle aside. So I know this is 3 centimeters. This is 4 centimeters. Can I find y? Yes. Okay, so let's label which one is hypotenuse. Right there. That's C, A, B. Alright? So now let's write down the formula. A squared plus B squared equals to C squared. A, 3, okay, so squared, B, 4. Squared, I'm looking for C squared. 3 times 3 is 9, 4 times 4 is 16. So we're going to add 9 plus 16, so let's line it up. 16 plus 9, 6 plus 9 is 15, 5, carry 1, 1 plus 1 is 2. So that gives me 25. So we're looking for C, that means I'm going to square root. That means I'm going to square root on this side also. Square root of a squared will give you the C, okay? And square root of 25, 5 times 5 from our timetable is, there you go. You only need square root of 25 is 5. Because you know that 25, 5 times 5. And only need to pick only 1 when you square it, which is 5. So now I know y equals to 5 centimeters. So that means right here, it's 5 centimeters. See that? Pretty easy, isn't it? Very straightforward, alright? Okay, good. Alright, let's look problem C. Now C, you're given, you say to find x, okay? We want to find x. And you're given a triangle. Actually, there's a 2 triangle attached to make a one whole big triangle, right? With a vertical. How do I know it's a vertical line? Because it's given as a right angle right there. That makes that line a vertical, all right? Okay? So, and then you're told this is 25 centimeters. This one is 20 centimeters. And then up to here, okay, for this. And this one is 8 centimeters. And you're asked to find x. That means you want to find the length of that. Alright? Now let's look at this. Let's look at this triangle right there. You know this length and this length. But look at this triangle. You only know this length. In order to find this, I need to know this. So how am I going to find this? That's why this triangle comes into help. It's going to aid you to find the length of that. Because why? This is a right angle triangle. See that? Opposite. This is the hypotenuse. This is C. Let's say this is A and this is B. I can use the Pythagoras theorem. A squared plus B squared equals C. I already know two sides. I can find B. Once I find this, now look at that. I'll know this two sides, able to find X. See that? That's the thing. That's the part. It's kind of like a puzzle. Alright? Isn't it so much exciting? It's so much fun, isn't it? That's the beauty about mathematics. You use what is provided to find the other one. In other words, once you find the other one, and then use that to find that X. Alright, let's do it. Okay, so let's first write down the formula. A squared plus B squared equals to C squared. Alright, so we know A is 20. Now before we do that, okay, before we put it in, we're looking for what? B. So we got to isolate B squared. Alright, so let's move A squared across. So it becomes B squared equals to C squared minus A squared. Now let's substitute. It'll be easier that way. Okay, so we know C is 25. So we'll substitute C with 25 and then we're going to square it. And then A is 20. We're going to square that. Okay, alright, so now 25 times 25, so let's multiply that. Okay, line it up. So 25 times 25. Okay, so let's do 25 times 25. 5 times 5 is 25, 5 carry 2, 5 times 2 is 10, plus 2 is 12, alright? So 2, 1, we're going to times with 2 now. So times 2, so we're going to start right here, right? So 2 times 5 is 10, 0, carry 1, 2 times 2 is 4, plus 1 is 5. Alright, so now we're going to add them. 5, 2 plus 0 is 2, 1 plus 5 is 6, so it gives us 625. So this is 625 minus 20 squared. Remember I told you 20 times 20. 2 times 2 is 4. You got 0 and 0. So you put 2 0 behind it. So it'll be 400. Alright? Or otherwise, let's do that. 20 times 20. 0, 0. I'm going to times with 2. I'm going to start right here. 2 times 0 is 0. 2 times 2 is 4. 0, 0, 4. Right there. Alright? So now we're going to subtract 625 with 400. 5 minus 0 is 5, 2 minus 0 is 2, 6 minus 4 is 2. So that gives me 225, which is B squared. See that? I'm looking for B, so I'm going to take a square root. That means I have to square it both sides. So B equals to 225. So we want to find a number. Now see that? Now let's look at this. 25, 20. So this one has to be smaller than 25. Am I right? This length, alright? Because this is the longest. So I want to find a number that has 5 in the back, because that number, why do I looking for that? Because see that 225, I'm looking square root. The identical number times should give me 225. So I want to look at a number that has a 5 in the back. When I times it twice, will give me 225. So what would be the lesser than 25 that has a 5 in the back? How about 15? 1, 5. See that? 15. So I can see 15 times 15. See if it becomes 225. So let's line it up. 15 times 15. Okay. 5 times 5 is 25. So 5 carry 2. 5 times 1 is 5. Plus 2 is 7. Okay. Then I'm going to 1. 1. Then I'm going to start right here. Okay. Let me write this one 25 right here. So 1 times 5 is 5. 1 times 1 is 1. So 5, 7 plus 5 is 12, 2 carry 1, 1 plus 2 is 2, 225 right there. That means 15 times 15. When you take a square root, you only take 1. So that means B equals to 15. That means B equals to 15. So now look at this. I got this length, I got this length. Can I find this? And this one is what? What angle is this? Also going to be right angle. When you have a straight line and a vertical line, which means perpendicular to that, which makes right angle here, also makes right angle on the other side also. Okay, so that makes this one hypotenuse. That means this is C, and if this is B, this is A. So that means A squared plus B squared equals to C squared. And I know A is what? 8. 8 squared plus B is what? 15. 15 squared equals to C squared. 8 squared is 64. 15 squared is, we already know right here, 225. And we're looking for C squared. Alright? So we're going to add that. 225 with 64. Okay, so let's take right here. 225, we're going to add that with 64. 5 plus 4 is 9. 2 plus 6 is 8. And then bring the 2 down. 289. So 289 equals to c squared. And I'm looking for c. That means I have to take a square root of, not to find c, that means I have to square root this side also. Okay, so let Mr. Mac write over here. Okay, so that means c equals to square root of 289, because square root of c squared is c. Alright, see, when you have equal sign, you can flip-flop. In other words, you can bring the c's in this side, this on the other side. Alright, as long as you don't change anything, just bring it exactly. Alright, okay, so now I want to find out what is square root of 289. Ask yourself, what number that has, when you multiply, will give you 9? Alright, okay, so what about 7 times 7 does give me 49, but you want something bigger than 15 and 8, because this is the longest side. So how about 17? Because 17 is longer than 15, or bigger than 15 and bigger than 8. So let's try 17. So let's take 17 times 17. So 17 times 17. 7 times 7 is 49. So 9 carry 4. 7 times 1 is 7, plus 4 is 11. 1 times 7 is 7, 1 times 1 is 1. See that? When I times that, I start right here, right? Now I'm going to add it. 9, 1 plus 7 is 8, 1 plus 1 is 2. 289 right there. When you square it, you only need one number. Alright, so that means c equals to 17. That means this is 17 centimeters. X equals to 17 centimeters. Pretty easy, isn't it? Far. So you find this one first, and then using that, you should be able to find this. Okay, good. Well, that's the end of the hands-on practice. Alright, good. Well, that should tell you. Before Mr. Mac can tell you, Pablo already told you. He said it's hands-on. It's time for quiz. Yes, it is time for quiz. Thank you, Pablo. And thank you for daring my students. That he dared you. He says what? Make sure you do it. Make sure you do your quiz, and then come and see Mr. Mac on the next lesson. Alright, my dear student. You are the best. You deserve the best. And that's why Mr. Mac is here to bring the best. And it's coming from the best. Alright? And I'll see you in the next lesson. Bye-bye.